Ella and Irene were writing about it in the Discord, okay? And maybe if you want to try together another example, so I don't care, okay? So do you have any more questions that you didn't have time to ask during the office hours? No. Okay.
Questions from here,
Questions, I don't know, other things, not about the quiz. Okay.
Yeah, then I had a question. I already asked it in the Discord, but I still didn't really understand how to do this. It's about the what you told me about the neuron, the Poissonic neuron.
Can you remind me, please?
I just don't. I think it's from 2018 or 17. The C part in question 5.
Yeah, I will let
We
you
talked about this.
You're welcome to share the screen and show us the question. Yes.
Okay, just a second. I will open it. אוקיי, מ-2017, דקה.
No, do you want to start
okay.
with this? Oh, okay, great.
This.
Right. So,
here.
it's the same question that I'm doing now, right?
It's not the rock.
So which one is it?
The encoding, the generate a new spike train.
Where is it?
Maybe I'll just show you the other computer, the other screen. Okay.
Okay. Okay.
So the other screen.
Right. So you see here, so you need to use a new spike train using the encoder given MLFP compared to M spikes. So you have your encoder, right?
Okay.
Because you calculated the STA given white noise and so on. Do you remember that?
Yes. Yes.
And then you get the stimulus for the LFP, I think, right? Or during rest?
We don't have stimulus for we have this stimulus. You talk about this? Okay.
And what do you use to compute the linear kernel? Is it used for the white noise LFP? Yes. You use it with the white noise, right?
Yes.
So yeah, now you have a linear kernel for the LFP.
Right.
And when you have this linear kernel, then you can use the other LFP, the real experiment LFP, to create spikes. So now instead of input as a stimulus for your encoder, you have an LFP for your encoder.
Okay.
And then you create the expected spikes, and you can compare them to the real spikes.
I just don't understand how I create them.
So when you computed in section B here, you computed the linear kernel, right? The optimal linear encoder. And this optimal linear encoder takes the LFP as an input and creates the spikes, right? This is what you get into your linear encoder.
Okay.
Or please explain to us, what did you do in section B? And then we can go on. The truth is that I wanted to solve together another question. So let's start with this and then come back. Okay, so Noah, can we go back to this question after the one that I will do now? Great.
Yes.
Okay. So we start now. The session is recorded, no? Yes, it is recorded. Okay. So we start now with the exam from 2016, part 2. And let's read together. So we have this file, which is a MATLAB file. Of course, I believe that you will probably have a CSV or something like that. So you need also the functions to read CSV, or maybe ask in advance, Cesar, what is the format of the data that you will get, so that you will know how to open it in your editor. So our data contains two matrices, variable green and red, and each one is 100 over 500. And each one contains the response of a neuron to visual stimulus with the color green or red respectively. Okay. Each matrix contains the response of the neuron during 100 trials and for 500 milliseconds with a 1 millisecond resolution. So far, so good. Okay. So we need to draw the ROC curve of differentiation between the stimuli based on the spike count of the response during the first 200 milliseconds. Okay, so we need to calculate ROC, which will discriminate between which two things? The red and the green. So we need to calculate distributions for each one of them. What should be the values in the distribution for each part of the vector? Right, and the distributions are two vectors that we use them in order to discriminate. So now what we need to think before, what we need to no, I mean, how do you say to not think in advance? The word for לתכנן, to prepare. Yes, sorry. Unbelievable. This was the word that I just forgot. So what we need to prepare is first to find what we need in any index of the vector, right? So what are we going to use? What do we use for neurons? So maybe I'll plot it again. Probably the question.
Spike count?
So we can use either spike count, but spike count is highly dependent on the length of the vector, right? So again, we need one vector for red and another one for green. What should be the value within each index?
The rate that we're given?
The rate, right. So we need to calculate the firing rate. And how do we get a distribution? Because we need a distribution, not only one value. So we need a distribution. So we need many times the firing rate. So how should we do it? Yes, Austin?
Have the spikes over all 100 trials.
Right.
Do we need to divide by 200 milliseconds because the length is constant?
So we are asked
We can't
about,
yeah, to do the spike count.
so you don't need to normalize by the length, but when you use a firing rate, so you kind of normalize it to 1 second, right? Each time.
Right.
Because firing rate is spikes per second.
If we needed to.
If we needed to, but another offer was right here, the spike count. What is the problem with that? If I have a beam, for example, of 10 seconds, 10 milliseconds, I will have, for example, two spikes, the most. But if I have a beam of 500, I can have much more, right? So I don't want to be dependent on the length. Therefore, I want to kind of throw it to the same dimension. So firing rate is not only a way to calculate the number of spikes given 1 second, like the average number or something like that. It's another way also to normalize our data. Was that clear what you just said? Okay. So we want to calculate the firing rate, and since we want to do it in ROC, we have to have two distributions. So the distribution, so we have two dimensions. One of them is of the spike trend, so it is irrelevant, right, of the time. So we don't want to average across the time. And the other dimension, when you have a matrix, always write to yourself, what are the dimensions of this matrix? So in this matrix, we have time over time. And then when we want to decide what is the relevant dimension axis for our calculation, we need to decide when we know what are the dimensions of the matrix. So in our example, it is irrelevant to take time, right? Like to average across trials or something like that and take time. In our example, it is the most relevant to take trials. Okay? So we know that we need to create two vectors of 100 indices so that in each one of them, the index is of the fire and grade. And please note that so far, I didn't write even one single code, okay? Because the idea is preparing the algorithm and knowing how should you debug it. So for example, when I wrote my code, I had a mistake and I mistakenly took the other axis. And then when I looked at it, I said, oh, look, there is a problem here. It is not the right number of indices that I need to have in this vector. So this is how I could get it. And this is also what you need to do during the quiz. You need to think what should be the sizes. Okay, so now let's see how we first create those twos so that we can start with the calculation of the ROC. Okay, so I really like to use the editor of Spyder when I write scripts, and the reason is that they have a very nice debugging interface. So I know that most people don't use it, and they have a very good reason, because it is very hard to load packages, okay? But I want to show you how I use this, and please look how do you have the same ideas for debugging your codes in the quiz, okay? So maybe there is an interface or a package that you can download in advance to your computer that will help you to debug, or that you can use plots, okay? So let's see some of the examples. So first of all, yeah, while solving, so you will see in a minute how I do it, okay? So let's, first of all, I want to, do you see my my screen, or should it be larger? Is that okay? Okay, and
Why shouldn't it be with a Y?
SciPy is with a Y, great, thanks. And of course, we will use NumPy, and of course, we will use Matplotlib, PyPlot, SPLT. These are probably the most useful packages that you need, and most of the times you don't need more than that. I know that sklearn is also very useful in this course, but if you don't have it on your computer, you can still solve everything. For example, I solved without it. Okay, so first of all, we need to download our math. So I'm just loading it, and the reason I'm using the SciPy is that it's converting from MATLAB to Python. Now let's see, where did I save it? I need to see that my data is in the same folder. Okay, so I write everything for the folder of reinforcement, and I don't have here the data, so I need to put it in the same folder. Okay, please note all of these things. Sorry. Because then you have problems in your code and you just don't know what is written, okay? So I just keep that all of my data and all of my scripts will be on the same in the same folder. Otherwise, it won't make it. Okay. So I wrote this line already, and I pressed F5, which means that I just ran my MATLAB, Python. I use MATLAB because I don't like Python. Sorry. And already when I did this, the first thing that I can see is I always look at the data that I have. And then I look, how do I need to open it? So first of all, the type is dictionary, okay? So I need to know how to extract things from the dictionary. So please note that in your formulas, you have an explanation how to extract data from dictionaries, because you might have the data as dictionary or as a NumPy array or whatsoever. Okay, so I see here that it is given as a dictionary and that I have these two keys of green and red that I need to copy them into new variables that I can work with them using NumPy. So what I do now is that I create green spike train and red spike train. And then I start to extract. So how did I do it here? Okay, so we have the mat, and then we take the key of green, and here it will be the key of red. And since I want to use it in NumPy, the next thing that I will do is that I will bring it as array. This is kind of a voodoo thing because NumPy knows how to read almost everything, but I always like to read it as an array and then to convert it to an array that it is easier for me to work with. So now I do, I take this and I make this one as type of float, okay? Right, then here, the red spike train. Okay, right. A lot of preparation just to have everything organized in the beginning. Okay, and now the next thing that I want to do is, we said that I want to create these two vectors of distribution so that I can start the ROC calculation. So I know that I'm going to need two vectors. The one of them is red. Sorry, let's start with the green. Green firing great distribution and red firing great distribution. Another important remark that I want to make, that it is very important that you have clear variables for you, not for Izar and not for anyone, because it really helps you. If I would just write here A equals and B equals, no chance that I can solve it, okay? So I always use very indicative names of the variables. So here I know that I need the firing grade distribution. And how am I going to use it? So the way for calculating the firing rate from a spike train is, how should I do it? I need to do something to the vector of the spike train. What should I do? Great. So first of all, I need to count the spike, right? Okay, but for how long I need to take it?
200 milliseconds.
200 milliseconds. So I know that I look again here at my variables and I see that 100 is the number of trials and 500 is the tiles. So it's the opposite than the one that is written on the board. So I need to take all of the first dimension and to take only 1 to, sorry, not 1 to 200. Here it's just 0 to 200. In the question, they ask me to take only the first 200 milliseconds.
No,
In the next one, we need to take the full 500, and we need to compare them. Did someone solve it by using sklearn by the
Yeah,
way?
I did.
Okay.
But I have a question then about this, because wouldn't it be the same if we just basically kept the ones and zeros that you have in the spike train and compared your ones and zeros with the hypothetical all ones for greens, for example? Because you want to compare your predictions and your reals. So if you have your prediction, which is zeros and ones, it doesn't matter what it is. It doesn't matter that it's a rate. It doesn't matter to, like, you can keep your zeros and ones, right? And you can compare those.
I didn't understand what do you mean by comparison. I know that in sklearn you
Yeah.
use the prediction and so on.
Yeah.
But I don't fully understand how to connect it to what we are doing now. I'm just cropping the data, right, for the first 200 milliseconds,
Mhm.
and then I sum it up, right?
Oh, so you're not gonna try to, sorry, so you're not gonna try to get the firing rate from the spike train?
The way that I do it is by summing up. And
Okay.
the sum, right? And then I need to write on what axis do I do the sum. So the axis will be 1, right? Is this clear why?
Okay, yeah, got it.
Is it 1 or 0? 1.
0, no, because you did it across time.
So for each 200 millisecond, I need to count how many spikes do I have, right?
Mm-hmm.
So I sum up for, I think that I sum up for each axis, for axis 1.
Yeah, because it's columns, right?
Yeah,
Mm-hmm.
right,
Yeah, then you have to start.
exactly. And now I need to multiply it by, I want it as firing rate, so I need to multiply it by, I have it only for 200 milliseconds, and I want to deduce about 1 second. So from 200 milliseconds to 1 second, it's multiplied by 5. Great. Okay. And because now I have the sum of the number of spikes within each 200 millisecond at each trial, right? Okay. But it's only 200 milliseconds, and I want to have it as a firing rate. So I need to multiply it to have it as 1 second. Is that clear?
It works without doing the firing rate.
It
You
works.
can keep it as the site count because it's 200 milliseconds. We wouldn't have to multiply it by 5 because our thresholds are just going to be, when we do the ROC curve, are just going to be shifted by.
Yeah, but again,
But
the idea here, please, we can go on reading the question because we needed to compare between 200 millisecond and the classification performance, which is the area under the rock, and do the same over 500. So if you don't normalize it to 1 second, i.e. normalize it to firing rate, you have a bias, right?
if you're comparing the same threshold from one to the other, but if you're just calculating the area under the curve, where your threshold is still variable, your area under the curve is going to be independent of where your threshold is.
But then how you go on to this one, because in this one, I also took a bin size of 1 millisecond as a function of the period taken. I think that when you want to compare between periods, it is not written here, by the way. I think it should have been written, but I think the right thing that you want to do is that compare them with the same scale. And if you have count, this is highly dependent on the size of the duration that you take.
We have it here, if it looks the same or if it's different at the end.
Okay, great. And by the way, now that we already read all of the question, we know that one of the steps will be to make this function more general. So one thing that I would do is have a variable called duration, okay? And instead of writing that the spike train is between 0 and 200, and then multiplied by 5 is multiplied by 1000 over 5, over the duration. Okay, So this is one of the changes that I would do already now.
Yeah, then I think it would be no, you're right.
Okay, and now we have the same for the red spike train. Okay. And so far, I think we finished about creating the two distributions that we need for the next calculation. Okay, and now, of course, that we have the problem. It has no attribute as type, and this is not true. Oh, it's not with big T. Great, thanks. Great, and now I can check. So you can do it by printing or whatsoever and see that you have a logical numbers because, for example, these numbers looks logical, right? And the size of the array here is 100 and 100. So it looks okay. Okay. And now the next thing that I highly recommend is now to plot your data. Okay, and here we want to plot the distribution. So the easiest way is to plot. If we want to plot distributions, the best way is to plot histogram. So let's create a histogram. So we have PLT figure, PLT hist of, we have the green, fire and gray distribution, and we'll give it the name. Give the name. Yeah. Thanks. And the same one for the red. And now we need to show the legend, and we'll give it a location at the upper right. And PLT show, so we won't have a problem. And then I can run it. And I go to my plots, okay? And now I can see my labels, which is green and red. So what would you choose as the H0 in this case? Green. Okay, so I write to myself, H0 is green and H1 is red. And of course, in the worst case, if the belly of your rock curve is just upside down, you just switch between them. Okay, so it's so I saw, for example, in the Discord that for one of you the belly was just non-symmetrical. It should have been just on the other side of the middle line of the diagonal. No, it should always, because the lowest is half, as you said. So you couldn't have it under half, right? Okay. The lowest is that both of them are just sitting on the same histogram. So you must have them as if they're even minimally separated, it's above the half. Okay. Okay. So now that we know the H0 and the H1 is red, so what should we do now?
Count the true positives and false positives?
Yes, we need to create two arrays of true positive and false positive so we can plot them for the ROC. And what should we have at each one of the vectors? How do we create these true positive and false positive vectors? Great. Okay, so we know that we take a threshold and then we move it along the possibilities. And then we calculate for the two distributions, the one which is up to this threshold, right? So what we do first, what I like to do first is write just my threshold. Here doesn't matter. Let's write XXX because it really doesn't matter for now. And I just write to myself, what do I want to calculate? So I want to calculate all those which are that, for example, for the red FR distribution, that it is bigger than Z, look how pseudo it looks, okay? I don't start now by syntax. Okay, and then I need to sum. So I find all of these which are larger than this threshold, and then I need to sum up all the numbers, right? And I need to normalize it by 100. Okay, because I want it as a probability and not as just the number of possible thresholds.
100 of the number of trials.
Exactly. Yes, and this is another parameter that you can play with. Excuse me?
Not surely.
I just wrote it for now.
Yeah, I understand that it's circle, but I don't understand the process that we're doing. I mean, why should we iterate through the range? I mean, isn't the threshold?
Yes, I didn't even write the range so far because I'm just writing to myself what I want to do with the Z. In a minute,
What is this loop for?
This loop takes this threshold and goes through this histogram
Okay,
and moves it right from
so we're
number to
trying-
number.
So we're trying to find the best threshold. I mean, what?
No, it's
why-
not finding the best threshold. For each threshold, we compute the false positive and the true positive,
Okay, yeah.
right? And then we concatenate it in a vector.
Right.
Okay. So now I need to add a few of the conventions. So this should be in how do you call it? The brackets, right? Okay. And okay, and this will be the one for the red. We call it the true positive, right? Because red is H1, so this is true. And for the false positive, I do the same, but with the grid. Okay. So the way I really like to write my codes is that I do it highly debugged. So that means that I don't write it only as one line, and then it's really hard to debug it. I have extra variables, and then it's really easy to see if the variables are okay. Okay, and then otherwise it's really hard, all this, mainly in Python, that they have all these millions of ways to save your data, then you don't find what is the right way to append. It's always a problem in NumPy. Okay. Great. So just for each one of the Z, I didn't concatenate so far. So let's start by writing our concatenation. Oh, and we have something missing here. We need to decide what should be the range. Okay, so what would you decide as a range?
100.
So it could be 0 to 90, but always take extras. Okay, so 100, 120, it doesn't matter if it, even if it will be the same, it doesn't affect the rock curve. I believe in you. Great, and now we can start the concatenation. So we create two empty arrays. So
Yarden,
yes.
why did we pick that range?
So we always take something which is extra, both on the left and on the right. Another possibility is to compute your maximum value from the distribution and take one above it.
But it was 90 because you see it from the graph because it's 10 to 90.
Right,
Okay.
but we take higher in the ROC.
So we see it from the graph.
We see it from the graph, yes. This is one of the reasons it is good to plot your graph. And if you want to, again, we know that in a minute we'll have to change a lot of things, for example, the duration and so on. So when we do that, maybe it will be helpful that we have a variable which computes the maximum for each possible duration or something like that. Or just take the max, which is probably 100. Yes.
And just in hypotheticals, we could even take it all the way to 500 or
Yes,
1,000, or, I mean, it would be a waste of computing time.
it will take 2 more seconds, you won't believe.
Sure,
Even
sure.
in this really shitty computer, sorry for language, but it really works fast.
Just as long as it's above our maximum.
And also lower than your
target.
minimum.
And yeah, well, as long as it's with outside of our range of acceptable values.
Exactly.
Okay.
Okay. So let's start by creating our arrays that we will need later to plot the ROC. So we have here the TP and the FP, and both of them are going to be empty.
I'm sorry, Yarden, why did you say lower than your minimum? What is our minimum
You
here?
always take threshold, which is low. For here, for example, the minimum is 10. And you will always take a threshold which is lower than your minimum.
Yeah, okay.
For the same reason as the maximum. Okay, so I created these 2 empty arrays. And now I start by the problems in concatenation. So we'll do, oh, sorry. So TP will be concatenated. And when we concatenate, we need to write here the 2 arrays and at what axis. So I'll use axis 0. And here I'll take the TP and the ZTP, right? The specific one for this iteration and the others that were before. And now I'm going to do the same for the FP.
FP1.
The FP, why?
I don't know.
The axis, since I created them with axis 0, so I concatenate to axis 0.
Okay.
Again, this is one of these voodoos of Python. I'm not fully sure that it should have been like this, okay? And now I just run it to see that everything is okay. And of course, always, I hate NumPy for this reason, because every time I concatenate, there are always problems. And the main problem is the input arrays, which must be the same. So the best thing to do is just to add here NumPy array and then reshape it to the size of 1.
You didn't wrote array, you just wrote array.
All right, this is also a possibility.
I think that might be a little easier in this.
It always does the same for me. So maybe just NumPy hates me.
And if you don't specify the axis, will it still give you the same error?
Let's check it. It's a great question. But I know that this one commonly really works good. So because it's all of the fact that you have so many possible ways to save data in Python, so it is also messy. The tuples and so on. Okay, so we don't want to have this array, and you offer not to write the axis. Let's see.
And the parentheses after 100.
The what?
The parentheses after 100.
Is that, yeah.
Yeah.
Okay, so you say that this should work out.
Right.
No, the same.
Okay.
And you say that maybe append should work out. So TP append like this.
But then find the
It should be just empty list. Yes, empty list. TP and FP should be empty list when you define them.
Empty list,
Yeah.
but then I cannot use the NumPy.
Then you just make it again It's very easy because you know how many we're gonna have, but
Okay.
whatever. wherever you're gonna wait.
Anyway, I know that if you have problem, ask Izar during the quiz. But anyway, I know that this commonly works out, that just converting everything possible to NumPy, and then so, and here I'll take back the axis 0 because I think it doesn't work without it. It specifies where at what axis to concatenate. So for example, if you have two vectors and if you concatenate to 0, so they will be just a long vector together. And if you specify to concatenate to the axis equals 1, then they will be a matrix. It's one next to the other.
Okay.
Great, it worked out, okay.
Question about the histogram that you plotted, about the H0 and H1.
Yes,
Let's have an example that the histograms are not shift one of them, but it's not shifted to the right, and if they are on the same thresholds.
yes.
So how do I say which the H0 and
So you take the one which is the longest one.
again
You take the one which is the longest one,
the one that
which is more skewed or a bit longer, that has the highest value as your H1. And if they are highly the same, you should have an ROC of 0.5, right? If they are exactly the same.
so which the one that they go further, will be the H1.
Yes,
Oh,
because there is some threshold that there is difference between the two distributions.
Yeah.
Yes.
Sorry, Yarden, can we hear the question?
Yeah, the question was that if you have, when I plotted here, it looks like both of them are separated from each other. But I saw also on Discord, and also when I plotted it, they were a bit more overlapped. It depends on the size of the bin that you take for the histogram. So let's try to take a smaller bin of 5, and then we can see what happens when we do that. Bin of 5. I'll just.
I think you have to write bins equals 5.
Bins equals. Okay.
5 without the parentheses, yes.
Okay, this one still works, but I remember when I did like 10 bins, or I don't remember the exact numbers, that they looked really overlap. Like they both start from the same place here. No, but anyway, how do you decide? You always take the one which is more right. It doesn't matter how it is more right. For example, it might be that it has just one higher value than the other, and then this one should be the H1.
Okay.
Okay, so we concatenated, and now we need to plot it. So PLT figure, and then we have PLT plot, and the x-axis is the false positive and true positive. And do we have anything else? I think that's it, right? Okay, and then we have this ROC over here.
Yeah, then can I just say something? If someone wants to try it on scikit-learn, can you please put it on the Discord as well? Because I got this exact plot with the function, but reversed. So if
Yeah,
someone figures
so-
out how they
Yeah. So Irene, first of all, maybe try to replace the false positive and true positive, because I don't know how did you decide that one of them is the H0 and the other one is H1. So maybe try to play with this. But anyhow, when you get something like this, just the right thing to do is just take it to the other side of the x equals y. And we should also have here x label Guys, it's really hard for me like this. I can also do really important things now. So we have the false positive, and I need to finish my PhD, for example. And the true positive. Great, okay, and the title and so on, you know, all the things that you need to add. Okay, so now we were asked about the same thing for a duration of 200, so we just copy and paste it for a duration of 200, of 500.
Yes.
Oh, and I forgot to, here I forgot, for the 500, there is a question. Here, please note that I forgot this one, the classification performance, right? Which is the area under the row curve. So who has an idea how can we compute the area under the row curve? Not only by using the sklearn. Right, it's geometrically, okay? So I just discovered today that there is something called the trapeze, right? So it could be either a trapeze, or I think it's also okay if you just sum all of them. But the problem is that, okay, first of all, we know that these are the y values. That in ROC curve, the y values are the TP, the true positive, right? So we can just sum all of them up. But the problem is that we have some that are identical to each other. So if you want, one of the ways to do it is like doing unique NP sum of NP unique, it is.
What is the
Right.
problem with having two of the same? I mean, if we sum them up, then we should
Oh.
have.
Sorry, it's not good also to have the unique, sorry. If you have the same, for example, if you have the same one and one and one and one. So this is the same dot on the ROC, right?
I was thinking about iterate through the values of y and just sum them up.
Right, but then you have some values of y and x which are the same. Because you took a threshold higher than the maximal. The maximum here is 90, right?
I wasn't following, so I might.
Was I running too fast?
No, it's
Okay.
just me, but
Okay, so if we had this maximum value of 90, and then we took 100 as the highest threshold, so from 90 to 100, we have the same number, right?
okay.
I mean, the calculation will be the same. Let's see it here. Okay, so here, we should have taken 90 as the maximal value, but we took 100 because we always take higher. So from 90 to 100, the ZP and FP are the same, right?
Okay,
But we still added them to our vectors.
okay.
So they are represented again and again by the same dot.
But where is it in the RFC? Can you show me?
So in the ROC, it should be here again and again and again and again. You have this dot of 1 and 1.
Until y instead of
Until you reach the range of 100. Here, this dot is computed again and again, right?
Okay,
Or this one also computed again and again.
okay,
So if you just sum up, you just add values which are not corresponding to your true value of the area under curve.
okay.
Okay, so the other possibility to do is this trapeze that I just discovered today. So what I would do is just print a area under rock curve for 200 millisecond duration is, and let's calculate it. Area under the curve, the rock curve. This one equals to NP trapeze of TP. And we have this one. Okay, and then We need to do it also for the 200. And also for the 500.
Can you also just calculate
Here.
what we just mentioned to the range of 90 and not
Yes.
and exclude the other?
And take the minimum, the same minimum, but you might also in between the same values, right? Because you might have the same dot.
I'm not sure.
For example, here,
No, because I'm not sure if we're talking about the same thing.
here, for example, it might be that the threshold here and the threshold nearby here
Mhm.
will just give you the same TP and FP.
TP and the positive and two positive in the property.
Here,
אני לא חושב שאני
Oh, wait, right.
לא חשוב, אבל אני שומע את ה-
I think it's supposed to be in the first function
yes,
after the actual positive, comma, false positive.
comma false positive like this. Great. So it's first the Y and then the X, or the other way around.
Probably, yeah.
Okay,
That's fine. Negative.
okay,
I know.
Great.
Also meaning, not with the line. No, it's the 50 and then. They got it.
so it should be first TP,
I think mine will.
TP and then FP.
Yes. but
So
then
it's first the
negative-
one.
It's negative because the indexes are the opposite, so if you take the indexes and sort them ascending, then it should give you a positive value. But I realized that and I just said, okay, if it's negative, then I'll just report it as positive because it's the same.
So this should be the area under the rock hair.
Yes, it's like 0.68. From what,
Okay.
from my. perspective,
Okay. It is possible. Yeah, it looks okay.
Yeah, then would it be possible to repeat what they say, please?
So the reason why it is okay, so we were just talking about why is it negative. So please look at the TP over here. So you see that this is descending, right? See, it goes from 1 towards 0. So when they're descending and you calculate the trapeze, so it equals -1 because of the way that the trapeze works. So one way is just multiplying by -1, and then you have the real number. So please note that when you use trapeze, you have first the Y, then the X, and if they are descending, you need to multiply it by -1, and then you have the real result. Okay?
Yes, thank you.
כאילו אם הוא מחשב מצד ימין לשמאל,
כן. He explains in Hebrew what we just said, that it calculates from the right to the left. From the right to left. Mhm. Okay. So now we have the bonus question. Let's go for it and then we'll finish because we have everything ready now. So in the bonus question, we are asked to explain the classification performance as a function of the period taken. So let's start by plotting it. Okay, so let's just take all the possible durations and for each one calculate the firing rate. Okay. And then we can plot just the classification performance, the area under the rocker, as a function of the duration that we took. Okay, cool. So we have we could have all of it, by the way, just as a function. I just write it like this because really we don't care about your code. So I kind of doing it like half draft, half something that I can debug. And there's something about functions which are inside our scripts that I think it is harder to debug them. So I always first start like this, and then only by the end, if I have time, I start to arrange them. But you don't need to do that. So you don't have to, I mean. So we can have this duration over here. And we can have, this is the bonus part. So we will have a loop that would take every possible duration from 0 to 500, but 0 is irrelevant. So every time we'll just take duration as duration plus 1. Okay?
What is the target of the question?
Sorry. So in this question, we are asked to draw the area under the row curve as a function of the period. So here we took 200 and 500. What about 300, 400, 1, 2, all the possible durations? Okay, so what I do here now is that I'm just taking any possible duration.
Yarden, I was wondering why do we have to put the +1, because the for loop is actually doing that, no?
The what? Sorry?
The for loop.
So the first value will be 0. So we don't have a duration of 0. So we can either take right in the range 1 to 501, or we can just write here index. And here do the duration as the index plus 1. Okay? Right, so now we calculate all the possible TP and FP, and we need to calculate for each one the specific area under the row curve for this duration. And now we need to save all of them where? In an array. Great, so we'll have area under the row curve, vec, and this will be an empty one. An empty list. And now we concatenate to this one. Would you like to try the append? Let's see if I did append here, or I don't remember. No, I did concatenate. So in append, I need to write what array, right? What value to append, and the axis.
Just need to write what you want to add.
Great. I don't need to write them.
But the
No need to write the axis.
and the beginning of code before the loop needs to be this. Not
Oh, right. If it is list, I know. But I want to use the NumPy append. Is this also like this?
For array, thank you.
It's back equal to back. No, NP array.
Right. So it's NP append. Right. I think it's like
You
this.
can make it.
You have to put it in variable.
Yeah, it's. But then I had this NumPy in the trapeze.
Yeah, but at the beginning of the line, you have to say that back equal NP append.
Ah, okay. So this one equals the append, and then I need to concatenate it to axis 0. Let's see if it works. Yay! No! Okay, so let's use the concatenate or the list or whatsoever you feel better with. Still, they are not the same dimension. Mm. No, it shouldn't have had this problem at all. Maybe I didn't save it before running. So I don't know why is it doing this problem. Beside annoying me. Here, concatenate is okay.
What's our end result? Like,
So
have, like,
in the
rough
end result,
consideration and then what?
yeah, so here we should have this figure that we plot. Just all the possible durations. I called it just yours and the area under rock curve back. And I forgot here just to write all the possible duration, which is and the range of 500 plus 1. This is the bonus.
The area is very-
Yes, it's for each possible duration. So let's see, this one is okay, and this one is okay. Right? Maybe I didn't copy it right. And this one is okay. So why is it not working after it worked? So this one was.
I think it's because you're trying to concatenate a vector with a value and they do not have the same dimension.
You say here the NP array. Oh, I hate it. Yes, Arceli, you were right. Okay. So this is the performance. Okay. So this is the performance as a function. So I need to add here. So the X label is the durations or periods that are taken, and the Y label is the area under the rock curve, and we'll give a title of performance as function of a period.
So in 500, the ROC is the best because it's in wire.
Yes. Yes, but you could also have here by 300, I think it's the same, right? You don't need to take off the 500. Here. Okay. I hope it was fruitful. So the main idea is just to show that your algorithm are reasonable, I think, and that you think before you just write the code. Right? Okay, Noah, there was your question, but you can go and I can answer Noah, or you can wait and hear the answer, whatever you prefer. But if you stay, I ask you to keep quiet, okay?
Can you but like solve it also like this?
What, the one with the Noah? I don't have another hour. No,
We need an hour to solve a question.
I don't know.
We have only 1 hour and a half. Interesting.
But now we were talking a lot. It took me half an hour to solve. You also, You also know how to code, you just need to be more confident. And when something is not working, call Izar like really fast. Because if there is a debugging problem, you just need to ask him. Here, something is not working with my NumPy. Do you know what is the problem? And then, yes, of course, he's your Google rabbi, we call it. So Noah, are you with us?
Hi. Yes.
Yes.
Yeah.
So I let you again share your screen.
Okay.
Great. So
Did someone need the first question for free?
yes,
You did,
yes.
but you're busy.
What?
First question, E,
E?
no one.
Yeah, Dan, quick question on the solution you had.
Yes.
Can we look at it again? Or to see something?
Yes. So so I share again my screen.
So with the range limited at 100, if for the really, really small section, if we had only 5 milliseconds, and there happen to be a few trials where there's 2 spikes in those 5 milliseconds, we'll have a firing rate much greater than 100. So do we need to adjust for Z in range and do a higher firing rate threshold? I think if you do increase it, those low range values might change.
So you're offering to take it until 1000, for
Sure.
example? Let's
That
look.
probably be.
Yeah, it's a good point.
What was the question, sorry?
So Austin just said a very good remark that maybe the fact that I took the small periods, then when you normalize it, yeah, you were right. So when you normalize it to firing rate over here, then and you take only the range of 100 for Z, you might have some firing rates which are higher than 100. So you kind of stop in the middle of the calculation of the Z. So Austin offered maybe take higher ones so you can have all of the possible Zs. And then you really have a better area under the rocker. It is not as good as the longer one,
No.
but still it looks more, yeah, it looks better, much better. Thanks. Okay, Noah, your turn.
Okay. Just a second. Okay.
So again, look at the question here. In the question, you're asked to create an optimal kernel, like in project 2. And how do you create an optimal kernel? You have a white noise, which is the stimulus, and you take the spikes and you make the reverse alignment. Do you remember? From a spike back to the stimulus. And then you crop the stimulus vectors from the white noise. Do you remember that? Yes. No.
Assuming you remember that.
I'll write it on board. So the model is like this. You want to have a function of any possible stimulus that its output is the firing rate, right? And the model says the following, we'll do it with a small r. So R equals R0 plus the optimal kernel convolved with that stimulus. And this is for any possible stimulus. Do you remember that? Great. And how do you compute the optimal kernel? So the optimal kernel is the average firing rate. This is only from the white noise. Okay, so it's the average firing rate multiplied by the STA in the white noise. And all of this divided by sigma square of the one. Do you remember that? Great. Now, what I say that if you look here at section B, in section B, you computed this, right? But it was not a real white noise. Please look, it is written here that it was an LFP. So instead of calculating the STA for a stimulus, you calculated the same, but for an LFP. Is that clear? And then you have this optimal kernel, which relates the LFP with spikes, right? And then what you're doing is the following. You take your calculation from B and you put it here in this function. And in this function, you need to calculate the R0, which is a DC, right, of your, which is the average of the firing rate in the real stimulus. Noah, is that clear where you take this R0?
No, I just, because I'm sharing the screen, I can't really see what you're writing on the board.
Okay, so you can go out of the, go out from it. Okay, so I said you calculated this in section B. So now you need to calculate this, which is the average rate in the real experiment. And you have the stimulus right now. And here, instead of the stimulus, since this was calculated for LFP, you replace this with LFP. And you have the predicted rate. Do you remember that?
Okay. Yes.
And now, given the rate, you take this rate and you create a Poisson neuron given this rate. And this is the prediction of your spike train. This is what you're asked.
I just don't understand how do I create Poisson neuron with this firing rate?
This Poisson neuron, how do you create a Poisson neuron with this firing rate?
Yes.
So I don't know if you're going to have only one number. You need to do it in the way that we showed the Poisson simulation, okay, in class. By the way, I must say, I would, if I were you, I would add to the formulas. There are some solutions online for Poisson simulation that I would probably just add them, because it could be just one line that you add here, and this one is the prediction of your Poisson neuron. Okay, why not? You might have a question like this one that Noah just showed, that you have this optimal kernel and you need to simulate a Poisson. It is one line. I think that there is no reason that you shouldn't have it.
Do you mean something like NP random normal or something like that?
Yeah, it's a very, it's like NP random normal greater than blah, blah, blah equals 1. And then you have this Poisson neuron. It's a very simple line. But if you have different possible R's, for example, you have for 100 milliseconds, you have 10. And then for 200 milliseconds, you have 20. Or something like that, then you just take this Poisson neuron and you just, for the first 100 milliseconds, you simulate the 10. For the 200 milliseconds, you simulate the 20. And if it's really like a function like this, or something like that. So you just need to do the simulation within every 1 millisecond. Okay, based on the rate that is given. But again, you have one line that you can copy, and I don't think these are, unless he wants to ask you to create a simulation of a Poisson neuron, but this is considered a very simple thing to do. So I wouldn't give such a question in a quiz. Did someone see a question like this? Like create a simulation of it? Yeah, it's considered a simple one since it's only one line. So add it to your formulas.
Yeah, then,
One moment, Araceli.
yes.
Ella.
Just to make sure, how the SPA is usually we do it with the stimulus itself, right? We cut the actual stimulus.
Yes,
But in this case, we're not doing the stimulus, right?
you're doing it with an LFP, so you have the same ID.
What does it mean then, LFP?
So
Like,
you
how
have
do you
this
know that that's what we need to use.
spike. It is written in the question, and
Okay.
you have a spike here, 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 and here.
Okay.
So you just crop this, sorry, this
Yeah, yeah.
and all of them, and then you average across them.
Yeah, because in the question we have also. there
The
are a couple-
stimulus.
Yeah, that's why it's so confusing.
Yes.
I didn't know which one to.
So
to
since
cut.
you're calculating the white noise using the LFP, this means that your model is for LFP and not for stimulus. And this is one of the things that you should also ask Izar during the quiz itself, because I think it
I'm not
really,
sure, like, just ask them which
Yes.
file should-
because in the question it is written to calculate it for white noise, so you just address the LFP as a stimulus.
Okay.
Okay? Great, see you on Discord and on Wednesday. And
Can I
come on.
ask something?
Sorry, Araceli.
Thank you.
Yes, of
Um,
course.
It's just that in the formula you said that the optimal kernel we computed for the LFP, but then you also said that the stimulus was the LFP, so I got confused because it's used twice in the equation.
So this is, I think, in the, Noah, can you show again your screen? So this is the MLFP. This one is from the real experiment. No, it's not here. In the doc, it was written that you have this MLFP and white noise LFP. So you use the white noise here. And in the real experiment, and the MLFP from the real experiment here.
Okay, perfect. Thank you.
And you can see that also on Discord. Maybe Sophie, if you can write Noah, if you can attach a link to the WhatsApp group of the question she just asked, because it seems like many of you would like to solve it. I think it's a good question to solve for a preparation. Yeah, okay, great. So 2008 is a very, all the last quizzes from 2018, 17, 16, 15 are very good quizzes to start with, or even to end with. Yes, Neil.
You know, when you get the feedback from the project.
Yeah, there were some bureaucratic problems with checking your projects. So I'll step by and ask if there is something new about that. And why do you really want it for your quiz? Okay, great. So I'll try to speak with them. And if it, she says that it makes her more calm to get the grades, but I would like to ask you, but what if it will be the other way around?
I will know how it will do.
Yeah. Great.
In this question, you are also asked to evaluate the similarity. So is it
Yeah.
something that you can calculate computationally or? based on the problems?
So I was also wondering, what did he mean by calculating the similarity? So First thing that you can do is calculate for the spike train the firing rate, right? And then you have two vectors of firing rate, and you can calculate the correlation between them. Another possibility, and I don't know if this is what is meant, is calculating the cross correlation between them. So that means how cross correlation by its name means how correlated are they by specific time lengths. So for example, it might be that your prediction is like this, like you have something like this, but the risk spikes are just about always after in the same time, and then a cross correlation would also give you this. So I think these are the two possibilities that you have, and all the others are from spectrums that you didn't learn, so, or information theory. So these are the possibilities.
What's the question?
The question of Kanike was how can you compute the correlation between the two spikes? So I said that one way is computing for each one of them the firing rate function, and then computing the Pearson correlation between them. And another possibility is to compute the cross correlation between the two spike trains. And if you have a lag that both of them are highly correlated, that means that the two signals are correlated, but within a specific phase or something like that.
Okay.
Great. So see you Discord Wednesday and so on. Ken.
Yeah, then can we just look at the drawing that you made in the board, the one in your right? Yeah. Ah, okay. Yeah.
about how we spider, even if it's spider on the ship.
How hard is it to use Spider? If you want to install packages that you don't have on your computer, you need to use the Anaconda and pip install and so on. And then you need to have the right version of Spider for installing, and then you can install a new one. So it is quite a headache. I wouldn't recommend it. And I also really love Spider, but it is true that it's really hard to work with it. Much harder than PyCharm. And I think that PyCharm, does someone uses PyCharm?
I have it, but I
Yeah.
use column.
So I heard really good things about PyCharm, that there are some, similarly to Spider, that they have also this variable view or something like that, right? Yeah,
And it's
you
not
have,
as good as in spider.
Ah.
It's very bad.
because Spider is MATLAB for Python. And I say nothing about MATLAB anymore in this course. Okay.
Take a back way.
כן. אני רק אראה, כי האמת שהיום, I'm answering a few questions in Hebrew about the project. האמת שהיום בשעת קבלה אני עניתי עליהן.
אני לא הספקתי לבוא, האמת.
הבנתי.
רציתי. לגבי השאלה הראשונה. ראיתי בתרגול האחרון שהייתי בו, שהשתמש, כאילו שרצית את עשית, כאילו עשית איזשהו, שרצית, אוקיי, מה אתה? אנחנו מדברים על דיקודינג, בעצם יש לנו את באחת הדוגמאות בשלב הראשונה לפי דעתי בתרגול, היה שם כאילו יש שם כמה וירי, ואז לקחת בעצם כל נקודה של קצב ירי, חילקת במקסימום כאילו, נכון?
בייסליין שהיה שווה לאפס.
נכון, ואז בגלל שזה כאילו בקוסינוס, אז כאילו יחסית כפל מטריצות עם 1-0, 0-1,
לא, זה בכל מקרה הצורה של population code.
נכון.
לא קשור לקוסינוס. הסברתי את הקוסינוס והסינוס, איך חישבתי את ה-1-0-1 וכולי. אבל בגדול אתה לוקח את ערך הוקטור המנורמל, זה מה שחשוב. המנורמל של הזווית שלך.
אבל כן יש קשר לקוסינוס והסינוס, כן קשור.
על מעגל היחידה.
כן. לא, השאלה היא, א', לא הבנתי בדיוק את השימוש בארק טנגנס, כי אני, כאילו כשעשיתי את זה עם ארק טנגנס בפרויקט, יצאו לי קפיצות, בגלל
זה אמור לצאת עם קבוצות.
לא,
זה אמור.
זה יצא לי עם קפיצות לא טובות, זה יצא
תראה
לי,
לי.
זה עם ארק טן 2, ועם ארק טנגנס יוצא משהו אחר, יוצא משהו
שהיה לך את זה שזה שווה לאפס עם הרקטיפייר?
מה זה שווה לאפס?
אמור להיות לך רקטיפייר לקוסינוס, נכון? יש עליו סוגריים כאלה?
כן.
פלוס.
כן.
אז אמור למחוק לך ערכים מסוימים, אז יכול להיות קפיצות. זה יצא נכון אם יצאו לך קפיצות, הדיקודינג הוא לא מושלם.
אני אגיד לך מה חשבתי. הרי כשעושים את הארק טנגנס, אז יוצאים ערכים שליליים, נכון?
נכון.
ואז כשאני רוצה לנרמל את זה, אז
כן.
אני מוסיף 360, נכון?
180, כן.
למה 180?
כי ארק טנגנס עבור חיובי, זה אומר שזה יכול לצאת ברביעי הראשון והשלישי, כלומר פלוס פלוס
אז
ומינוס.
אולי זאת הייתה הבעיה.
כן.
אולי זאת הייתה הבעיה, אבל לא על זה אני מדבר, השתמשתי פה באיזושהי פונקציה אחרת, שכאילו,
שפתרה את זה.
שפתרה את זה, כן, וזה מה שיצא לי בסוף. עכשיו,
לא, אבל זה לא אמור לצאת ככה, זה אמור
אז
לצאת
זה אמור לצאת-
שהדיקודינג הוא לא טוב.
זה אמור לצאת כאילו כזה.
כן.
אבל זה מוזר, יצא לי מוזר, כי אני חשבתי, המחשבה שלי מאחורי זה הייתה, שבגלל שיש חפיפה מלאה בין הנקודות הכי נמוכות לנקודה הכי גבוהה פה, אז כן יש איזשהו זיהוי. כאילו שהפופוליישן קודינג הוא כאילו, הוא באיזשהו מקום, כאילו זה ש...
כאילו הוא מכסה על הפער הזה שזה
כן.
שווה לאפס.
כן,
כן.
אני אגיד לך, אפשר לשנות את זה בשנייה, זה לא באמת...
זהו, כי אני זוכרת שזה, גם כשהתחשבתי בעניין הזה של 180 מעלות, זה עושה לי את הבעיה הזאת.
איפה עוד? לפי דעתי, זאת אומרת שב-180
הנה,
משהו לא
כמעט,
כזה, כן, לא כזה, זה,
כן,
אני צריך
אבל
לשחק
כן.
פה עם, אני צריך לשחק פה עם ה...
אבל כן, אני זוכרת שהוא יוצא לא טוב. בגלל שיש לך נוירונים שלא יודעים להבחין, אז הם נותנים את אותה פרדיקציה. אז אם אתה לא מתחשב בכולם זה עובד. אז מה שאמרת זה דווקא ל-winner takes them all.
כן, לא יודע, בכל מקרה זאת לא השאלה שלי. אז זה גם, חשבתי על זה שזה מוזר, כי פה יצא לי אותו דבר, כאילו שזה איזושהי קורלציה מושלמת. העניין הוא שברגע שאני מוסיף את הרעש, אז שוב יוצאים לי ערכים שהם שליליים. ואז על זה, אם אני מוסיף את ה-180, 360, יוצא מצב כזה, שבהתחלה יש לי ערכים שמגיעים ל-360, ובסוף יש לי ערכים שמגיעים ל-0. ואז זה גם משפיע לי על ה-RMSE, כי זה לוקח בחשבון את כל אלה. וגם אני לא מצליח כאילו, אני לא מצליח להוריד את זה, כאילו ניסיתי לעשות פה איזושהי, כאילו ניסיתי להתחכם
איפה רעש רשום שהוא צריך להוסיף אותו אחרי או לפני הרקטיפיין?
לא רשום, גאוסיאן 0 עם מופיע תקנה.
תעשה רקטיפיינג אחרי.
הבנתי מה זה כבר, זה הבנתי.